Well, I see Jeff just got in. Jeff is in New York with the NAB show, and he has taken time off to be with us, which I think is pretty neat. Are you on site or are you in the room, Jeff? He's still hooking up.
Yeah, too many buttons. So I'm trying to figure out how to work a mobile. No, I am on site. So we're at NAB Radio, or not NAB Radio. What do we call it nowadays? NAB New York.
Yep,
But standing, and I assume you can hear me okay.
I can hear you fine. You sound
By
just
the
like
way, I
Jeff
like the beard.
Welcome.
That's. I hope so.
Well,
I got to introduce you to the competition.
okay, if you'd like.
Barry's lunch. So I just showing her. So did you get her help?
I think so. Yeah.
Oh, good deal.
Hey.
So, we're just sorry, we're kind of running around. We had somebody coming into our booth looking for help from one of our competitors, and it's like, hey, go to their booth. But anyway, all good. So how are we doing today?
Well, we're doing reasonably well. Mark just showed us his what Nautel is that you have, Mark?
A GV20 with HD and dual exciters, all the options.
GV20 and
oh, very cool. Which one?
It's KL.
Oh, go ahead.
We had an interesting phase loss this morning. One of my phases went from 238 to 208 for about 30 minutes. And,
Ooh.
Transmitter didn't care. It just kept going.
Yeah, I mean, you can if you lose one phase completely on a GV, you've got about a 66.7% chance that you'll still stay on the air even at reduced power, because the low volt supply goes across two legs, and as long as you don't lose the one phase that's common to those two legs, it'll stay running.
Oh, the other thing I've had happen just fun is, and I since changed it, but I have a UPS, the UPS option running the exciters and all. And one time I lost that phase. And so 30 minutes after I lost the phase, everything shut off.
All
now,
right.
and we've changed that since then. The UPS interface now has its own internal mean-well supply. So if your UPS fails, it's looking for it's still in parallel with the regular main supplies. And you can have, unless you've got no mains and no UPS, in which case it's irrelevant. You're off the air anyway.
Yeah.
Okay.
It was interesting. I'd never seen one phase be low like that. It was just.
I was at a station some years ago where they had a UPS. The gates won, and they had a 1 kilowatt UPS.
Yep.
He couldn't figure out why he could never make power.
Yeah, you do need efficiency is not 100%. So,
so, well, might as well get started here. And as everybody can see, you're at NAB New York, and you have made some time for us to talk about grounding, which I appreciate.
Yeah,
folks do. And so let's let you get started, Jeff, and wherever you'd like to begin.
Well, I figured we'd do it more as a discussion than I mean, I can run a presentation if you need me to. I'm on the phone, so that'll be an interesting challenge, but that's not impossible. But I mean,
discussion
doing
is
it
fine.
as a discussion is, yeah. And oh, look at that source for the four. So I'll answer John's question first, because we will talk.
There you go. What is a source for the large ferrite cores that can fit around a 3-inch or 4-inch coax? Jeff, you're muted, and I'm going to unmute you here.
Thank you. Yeah, I hit the wrong button and muted myself. It put me in driving mode.
Okay.
So the short answer is the only source I know of for the big ferrites is us. And having said that, we buy them from Magnetronics, so they will sell to the end user, to the consumer, but they do charge an arm and a leg for it. which I guess makes us look better because it means we're not overpricing ourselves. But yeah, I mean, we can certainly quote those. I can send you a link to the OEM and you see if their minimum buy isn't too obscene, then you're certainly welcome to buy them direct. It doesn't hurt my feelings.
All right.
So on that one, reach out to me. We'll help you out.
Okay. Jeff, as we get started then, ferrites, they're not actually grounding, but they're a good part of what keeps the surges and the spikes from causing great transmitter issues.
Oh, wave at John.
Hey, John.
Barry says hi. Figured that would happen. You knew it was going to happen. I did it on purpose. But yeah, so the ferrites are, I call it a triumvirate, a trilogy, if you will. You need more than anything the grounding and the surge protection. Those are the non-negotiables. If you don't have those, you don't have good lightning protection. The ferrites will help a little if you are in a situation, John, you drop something. But if you're in a situation where you are seeing some failures, even after you think you've done the best you can with the grounding and the surge protection, then they might make a little difference. And the reason is that transmitter sites typically are built 180 degrees backwards. You put the power coming in from the pole on the street. You have the RF going out to the big lightning rod in the back field, and you hang all the equipment in the middle. So what we try to do with lightning protection and grounding in general is to provide a path for current to dissipate, whether it's coming from the lightning rod to the power lines or whether it's coming from the power lines looking for ground. In the vast majority of cases, it's coming from that big 1,000-foot or 2,000-foot or whatever foot lightning rod in the back field, the tower itself. So what'll happen, because Earth has a resistance, when the current comes down the tower, it hits Earth. Well, E equals I times R, so you develop a voltage at the base of the tower, and then eventually you need to find a place for that current to dissipate that isn't the base of the tower. So that's where the surge protector, being a bidirectional device, lets you send the surge out to the AC lines and all the millions of miles of wire and ground that the power company provides. So that's why when I say grounding, you can't have grounding without surge protection.
Okay.
Well, you can, but it's not going to solve your problem.
Okay, well, let's start there. And you say we start backwards. Where would you start? At the tower?
So at the tower always. So think current divider. Okay, so you're 100,000 amps of current coming down this big steel lightning rod, finding a way to ground. Well, now ground potential is spiked high because E equals I times R. So you start spreading out, looking for other places to dissipate. So, the first thing you're going to see is the big coax. You're going to follow the coax. And ideally, at some point, that coax will connect to a ground strap connected to a surge box, which will give you a path to the AC lines. But if you don't have that, then the next thing you're going to run into is probably the output of the transmitter, and either the transmitter ground or the power supply or whatever to get out to the AC lines.
So
because again,
what would you recommend?
What's that?
What would you recommend?
So that's where the shunt type surge protector is critical. And I mean, like a series protector, even the expensive series protectors have input and output shunt legs. So it's the shunt part that's what we really, really care about for antenna type lightning protection, because the current coming down, MOV doesn't care whether it's clamping a surge from ground to power line or from power line to earth. So it's a bidirectional device. It's irrelevant which way the current's flowing to it. So, and again, remembering, like I said, E equals I times R, I keep saying it, but if ground has a resistance of say 2 ohms per foot, then if you're running 100,000 amps, after you've gone a foot through the earth, you've developed a potential difference of 200,000 volts, right?
Mm-hmm. Well, I would say that the majority of sites that many of us have seen you have your transmitter going. Now I don't know, AM and FM are going to be a little different, aren't they? And I don't know which one we
A
could.
little, but not an awful lot.
Well, you're going to come out of the
Because
transmitter.
I mean,
You're going to go through either a
Mhm.
filter or an ATU and then a loop to the tower.
right.
Where would you
And
put this?
so
Where would you put this surge protector?
so the surge protector's on the AC lines, not on the RF line. So I always put the surge protector at the entrance panel. Okay, because the wiring to the electrical entrance is going to be the smallest gauge, which means highest resistance. And again, current divider, we're looking for the lowest possible resistance. You can get coaxial surge protectors. I saw, I think it was SCMS was advertising Fred Francis's quarter wave stubs recently, which helped because they're a DC path, but it's diverting. But the MOV AC line protector, the surge protector that I'm referring to, goes directly off the main entrance, the main breaker panel. Okay.
Okay, yeah, I misunderstood that you were wanting to put a surge protector both on the AC and on the tower.
Well, I don't. So the surge protector, one end goes to ground, one end goes to the AC lines. And on an FM especially, the tower is ground, right?
Well, that's my next point. You have a tower ground and you have an AC
Yeah.
ground, and sometimes you have a ground ground.
And you better have all three of them tied together. So, and for what it's worth, and here's where it gets kind of funky. So if you pick like tower ground as an example, a lot of old electrical inspectors will growl about connecting the AC ground to the facility ground. But Article 250.4 of the NEC has required that since about 2010. So facility ground must be connected to the electrical ground. Now, here's the caveat. Different states have different rules. Some follow different variations of the NEC, so it depends what year. Some states don't follow the NEC at all and opt to only follow state code. Mississippi would be one example. I think Arkansas, last I checked, there were 4 states that did not specify NEC as the defining code for state electrical. So you have to use a little bit of, I guess it's always best to speak to an electrician, but ideally, if you can bond all the grounds together, your life will be a whole lot better with respect to lightning failures.
Well, for an AM station, you have a lot of ground going on. All those radios out there.
Okay, well, no, that's a counterpoise. That's totally different from a lightning ground. So although it's in the earth, you don't count the counterpoise because it's low gauge wire, typically 6 gauge soft drawn copper. And it's the RF return path, not necessarily a safety ground. You know what I mean?
Yes, I do.
Yeah. Now, the advantage to it is that it does help to lower the overall ground resistance, which is its whole purpose. Because in an antenna, any antenna, but especially on an AM, so you've got the antenna resistance, you've got the series resistance, and you've got the radiation resistance are the 3 things that make up the resistance of the antenna system. Well, the antenna resistance is pretty much fixed, nominally 50 ohms or whatever. The radiation resistance is a product of physics, but the ground resistance, the series resistance, we have control over. And the more copper we have in the ground, the lower we make that, which means the more efficient we make our antenna system. So that's why we do the radials on an AM system, for what it's worth. But again, as a lightning protection standpoint, they don't do a whole lot for that. You need to get down further into the earth for that. I'm just flipping through that. So I've never done Zoom mobile. I'm flipping through all the screens to see who I get to see here. Oh, Mary's sitting there looking bored. And my video's frozen, Steve says. So either that or I'm just not moving that much because I'm paralyzed.
Well, Jeff, let's tackle this a little bit more because there are a number of different ways to ground things, whether they be copper, the chemical things that are out there, uh, or a ground rod, and
Mhm.
most people will say, for instance, most of the tower guys will say after 10 years, a ground rod probably isn't a ground rod anymore. Uh,
They'll they'll erode. Yeah, I mean it'll vary depending on the kind of rod, how it was installed. I mean they could last 10 years, they could last 20 years. The other thing that happens if you're using a clamp type connection instead of an exothermic bond is that they'll start to oxidize and become a higher resistance. So the where the ground wire goes to the ground rod. And this is why I recommend CAD welding whenever you can, or Silphos, silver solder, whatever, some exothermic connection that can't oxidize like a clamp can.
yeah,
So yeah, that's one of the other. Go ahead.
those look funny when you see them, the little clamp sitting there after so many years. All right.
See, anyway, um, so the other big thing that we don't talk about near often enough is why grounding as a whole is something that we tend to overdo almost as much as we underdo. Um, I've run into sites where you'd have main transmitter grounded to standby transmitter, both of them grounded to the phaser, all three things grounded to a common point connection near the surge protector. And you got so many ground loops that you got no idea where the current's going. And this comes back to that whole starting at the tower, working your way back, pretending you're 100,000 amps and finding places that will get you either to earth or AC. And remembering that every time you have one of those junctures where you can go either to earth or continue on your path, then you want to keep the resistance as low as you possibly can in the path toward ground, toward earth. And so that's the kind of thing that we tend to focus on a little too little, I guess, for lack of a better phrase. All right. Anyway, I'm going to have to describe it. What I will do, though, Barry, is send you a copy of my grounding presentation.
Okay.
And that way you can make it available to the attendees as well.
All right.
Okay.
Very good.
Yeah, that's like I say, antenna at one end, the transmitter in the middle, and the AC at the other end. So the more we can establish a common point. Now, the other thing that I really wanted to touch on is halo grounds, because everybody loves them and I don't.
Well, before we
And
get to that, let me just toss into the mix here. There is one more thing besides the AC power, the transmitter, and the stick. You have all this stuff coming in, whether it be the computer, automation, remote control, telephone, STL. Grounding is going to be
yep,
important for all of that, isn't it?
it is. And beyond that, most of those things will have either their own ground wire or a shield that should ideally be all tied together. Again, you can throw some ferrites in there to help sort of, and the purpose of the ferrites twofold. So we're going to jump into ferrites real quick, but ferrites both. So anybody who's a ham knows that you can take a ferrite, wrap a wire through it, and create a choke. And so Steve Schultes from WNYC standing in front making faces at me. But this is the problem doing anything live. So I should have just hidden in a corner somewhere, but there are no corners in this place. It's round or something. Anyway, so the ferrites, you wrap the wire around them a bunch of times and you create a choke or an inductance, which adds an impedance to any high frequency component. So it makes it less attractive path for the lightning energy. So recommend that for any Cat 5 or Cat 6 or phone lines, for example. Power cords to every device. just to cut down on the amount of stuff you do blow up on a lightning surge. And that doesn't matter whether it's coming in the AC lines or ground potential spike an eye on a strike. Okay. Now getting back to the cabling, basically everything ideally will have a connection. And somebody in the chat had mentioned like everything gets its own ground connection to a single common point. And that's, yeah, star connection is a good description. So that's a prime example of what I'm trying to talk.
So one of the important things you would say is for when you build a station or remodel, whichever, is to identify a particular place as your ground point.
Absolutely, yeah. I mean, you've got to. I keep throwing myself into safe driving mode and automatically muting myself, so hopefully that fixed it. But yeah, you do have to establish your common point for the grounding. And whether that common point is, ideally, my personal preference is to keep it close to the surge protector over by the electrical panel, because the electrical wires, again, will tend to be the higher resistance because smaller gauge. So you can run a big old heavy strap from the panel over to your transmitter, over to your coax, and establish your common point at the electrical panel, and then just bring everything to that point. A lot of other people will put their bulkhead or their ground point where the coax comes through the building and put a coax ground kit, and that's fine too. But at that point, you still need the connection to the mains panel, remembering to tie your AC and your RF grounds together.
Do you recommend folks to test that from time to time?
You can get testers for it, and if you don't have 100% exothermic connections, like if you've got any clamp connections or those wires going into the screw-on terminal things, then absolutely you should test it on occasion. And that test, I mean, how much you invest in grounding in general and how much you invest in testing it will depend partly on oh, there, Mark put a couple of links up, I assume, to ground testers. But yeah, how much you invest in that, it will be determined by a couple of things. What's the chance of getting hit by lightning where you are? You know, I mean, if you're in the Midwest, you're probably going to put a little more. If you're in Florida, you're going to put a lot more. If you're in Washington State, maybe a little less, because they tend to get a lot less lightning. By the same token, if I'm protecting like a VX1, like the one sitting over to my right a little ways, there, gratuitous commercial right there. But if I am protecting a VX1, which runs about $7,500, give or take, versus a $250,000 worth of HD gear, I'm probably going to invest a little more in grounding to protect the HD station. So, you know, it's a higher loss if I don't.
I think it's important to realize that ground is, again, not always ground, and this is what we have had Tom LeBert on a few times, and of course he's into the chemical grounding systems.
Yep.
Now, when we talk about ground, what should someone measure to ground? How many ohms?
As little as possible. That's my whole general non-answer. Because you know, it's going to vary depending on your specific situation. So yeah, that's the kind of thing, you know, fractions of an ohm ideally, but an ohm or two in some cases is going to be the best you can do. Remember that a lightning strike can go upwards of 100,000 amps. So it's again, E equals I times R. So the voltage you develop is purely determined by your ground resistance. So, and that's something Tom and I had talked a little bit offline a couple of weeks ago about this. So that's something he and I are going to have another conversation, because I think we agree on almost all of it.
Okay. Again, anyone with a question or a comment, please feel free to join us or raise your hand if you'd like me to acknowledge you. If you're watching us on the YouTube live, enter your comment in the chat box and I will relay it to Jeff.
Question.
Thank you, Harold.
Yeah, it's interesting. I think it's voltage differences that will destroy equipment. We have birds on wires that are, well above ground, but they're not destroyed. So as long as everything is swinging together, rather than having a voltage across it, how critical is it that we actually have stuff at ground?
I agree with that. The big challenge becomes, since some stuff is referenced to ground, then you almost have to have everything referenced to ground. Whoops, there. I going to say I'm sitting here babbling away and I'm muted again. I do agree, but yeah, the ground gives us a stable reference across the board. That's where the ferrites do help, because the ferrites will let us reference, like they'll give us the ability to bring the shield and the center up at the same rate, and like you say, keep the potential difference the same. And yeah, whether it's 5 volts to 55 volts, or whether it's 500 volts to 550 volts, as long as that potential difference stays the same, transmitter doesn't care.
Yeah, it seems like, if we just put in a copper floor and have everything tied to that, and then it is also the stuff brought in from outside, whether it's telephone lines, power lines, coax, or whatever. If you can get that tied to that same copper reference, then I think we're going to develop fewer voltage differences. But thank you.
I've got a question for you.
I agree. Yeah, go ahead.
Okay. I've redone a few towers recently, and of course we have a wooden fence around it. And every corner of that fence, I drove a ground rod down, put ground strapping all the way around to read every ground rod, and then put ground mesh completely covering the whole middle of the where the tower, all within the fenced area. And then went from there, went to the transmitter building, which is not very far away, and make sure everything was grounded around that. Also, I was thinking that should be enough ground protection for the transmitters and most equipment inside the transmitter building.
Right, and it's all tied together to a common point, so that's a wonderful system. The ideal, though, again, like I said, because at this point, if you get a big surge coming down the tower, then that ground potential spikes high. If you've got a good surge protector installed, once you get more than the clamping voltage above the AC line, so 490 volts with a 250 volt surge protector on a 240 line,
right?
Then the surge protector clamps and dumps any excess voltage out to the AC lines. So that gives you a little extra, but you do need the two. You need the surge protector and the grounding. And what you've described for grounding, it worked perfectly, I think.
Okay, because that's the way I like it, because especially for AM, because that base ground right below the tower, I think is the best system for getting the signal out. And if you want to go out farther, that's fine. Then you run the radios from the outside of the fence as far as you want, as far as the height of the tower at the most. And then there you go. But generally, you get a good signal with that complete ground underneath the tower. I mean, heavy ground underneath it. It completely covers everything.
Your picture says iPhone.
And
your picture says iPhone. We don't know who we're talking to.
Oh, this is Bill. My picture went away?
Yeah, it just says iPhone.
Oh, no. Can you see me now?
Now we can see you.
Oh, okay, because I just had it on the tap side. Sorry about that. But yeah, I think the heavy grounding.
I'm going to have to disconnect soon anyway, because I got to get going.
All right. Thanks for the info.
I agree because two reasons. It also helps to keep your radiation resistance down so that, like you said, you get a much more stable AM performance.
That's what I thought. Thanks.
Hey Jeff, Mark made a good point. I've been considering buying one of these three-stake ground measurement systems. Amazon has them pretty reasonable. I think they're less than $100. Mark, you might have used one before, but it's all about getting a low ground resistance and measuring, knowing what that is seems important. But if you get the professional models, they're not cheap and for something you don't use very often. Has anybody used the Amazon before? I guess Mark might have. I don't know, but.
I think they're like the
Yeah.
Ultra VNAs. I mean, they're a great device for something you don't use very often.
Yeah.
What I use it for is just I don't often believe it, but I'll take measurements at a site, make a good set of notes as to how I did the measurements and where and everything, and then repeat it, a year later, see what I get, see what the change is. I'm not looking for an absolute number as much as why did it change?
Relative.
Right. Looking for the delta.
Yeah, like you do with a lot of other things, and if you get a big delta, you got to figure it out. But then the question is, what's a big delta? So I'm just kind of learning as I go.
Yep. Oh no, that makes perfect sense. All right, I'm going to skip out. I've got a customer here waiting on me, but thanks very much for the chat, guys. And certainly any questions you can shoot them to Barry and he can find me, or shoot them to me direct. I think I'm easy to find.
Well, thank you, Jeff. We're not sorry that you have a customer. No, we're very happy about that.
I'd rather be busy than bored for sure. All right, thanks very much, folks.
We'll see you later.
See you. You bet. See ya.
Yes. Ray, you mentioned in your comment here about looking for a ground of under 10 ohms.
Yeah, they're standards. I mean, we have civil engineers, and when they're putting in a facility, they'll measure this. And this is my day job, and for these big, expensive, facilities that they put in, they measure that. I know they like 5 is preferable, I guess, but it seems like that's what it's all about because it's a voltage divider problem, like Jeff said. And man, if you can get that thing down, the lower you get your ground resistance, the less problems you have. Seems like to me. One thing I've read also too is that y'all correct me if I'm wrong, but I've heard that a series of shorter ground rods, space 2x the depth is usually preferable to a really long ground rod because of the inductance of the ground rod. So I think at our station for lightning, we've got 16 8-foot ground rods spaced all around the place, but I don't know. Be interested to see what you guys think about that. This says because a longer rod will have more inductance, and I guess it sort of makes sense.
Well, Tom LaBarge makes that very same point, that the more that you have, the better. And the question becomes how you bond to that ground, whatever it is, whether it's strap, ground rods, or a chemical thing. Because as Jeff said, in different parts of the country, you have different issues. And you want to make sure that you have a real ground, in the sense that you don't want that pulse to come down the tower and go looking for something in the transmitter room when you want it to go down into the ground. And especially when we have so much now in ICs and computerized things and such, it becomes much more critical than it was in the good old days. Well, one of the things that we talk about and have talked about several times over the months is preparation. You can't prepare for everything. You can't prepare for 150-mile-an-hour wind. You can either build it the first time or realize it's going to come down. And I'm amazed, and I don't want to say gratified, but I'm impressed that the majority of stations stayed intact. I'm disappointed at the number that don't have generators. Let's go back, because Ray brought up this question that we weren't entirely done with grounding yet. And he mentioned static dissipators. And there are a number of different ways to deal with lightning to augment your safety. One of them is a simple pole at the top. You've seen a lightning rod at the top of a tower. Then there are the ones that look like a pincushion that Dave Rose, engineer out in Oregon, used to come down here and sell to a number of stations. It was just, just this pincushion. The idea being that it was able to dissipate some of the lightning, and he would bring a Tesla generator to show that it would. Maybe some of you have done that, put that on the top of your tower.
I've been using a thing called geostats that we buy commercially on my hand towers. And the theory of those is they don't do much for lightning, but in the run up to getting a lightning strike, there's static in the air, and these things will dissipate and keep the static charge from building up, which is very damaging to IC type circuits.
Barry,
Hi, Marvin.
yeah, I'd like to mention that during my KFI days, early on, we suffered lightning strikes from time to time. One time it destroyed the transfer switch from the generator, and I forget what the other one was, but then I don't remember the name of the company, but they offered to come out and put some of those, I called them bottle brush things, up there. And I think they put the tower was a triangular shape, and they put one on each three corners. And after they did that, I never had another lightning strike. At the time I was doing it, I thought, I don't know if this will work or not, but I think it was a $5,000 project. And I thought, well, this is worth a try. And it really worked. Unfortunately, when the airplane hit the tower, I got to see those things again when they were laying flat on the ground. But now with they don't have them up there anymore because they put a capacity hat on top of the tower. And I guess that is a big static drain also. So they don't have those in service anymore. But while they were there, they certainly worked.
I think Ron Knott built a lot of those in the two companies that he put together up there in Farmington, and kind of looking right now for a picture to show. Let's see. Oh, he's got a little dissertation of it here. Ron has passed away, but his company is there and still provides the static dissipators.
Are you talking about ones from Knott, N-O-T-T, in New Mexico?
Mm-hmm.
Yeah, I've got their website up. We've been using those, especially the big Eagle's Nest EN-1 on top of our 1,000-foot tower here in Oklahoma. It seems to be working. That's it, yeah. And we some of the side mounts too, the side the GS3s that go along the side, I think is what they are. Or maybe it's the GS1. Yeah. We have along the sides too to help dissipate the charges. Yeah, GS3s along the side.
Let's see.
They look like bottle washers.
I was thinking also about the grounding. Since the FCC did a ground conductivity test, that's going to make a difference also for your grounding.
Absolutely.
So if your conductivity is really good, I'd have a lot of ground rods. If it's not, I don't know if I'd put more in or less in. I'm not sure how that would affect the signal from the tower to how far out it's going to really go.
Now, do those really work if you put them on the side of the tower, though?
No, I don't put them on the side. I put them in the corners of the fenced area every corner of the fenced area gets a ground rod. It had 6-foot ground rod, drove all the way down. And then I connect a ground strap to every one of them straight across the base of the fence itself, and then take copper mesh and layer that in the area right below the tower and make sure every piece of ground is covered by that mesh from the base of the tower out to the edge of the fences. And that seems like it gives a great ground system.
I have heard from Ron and from others that installing these things make a big difference. I can recommend, if you want to know more, it's discussed here on the site at NOT, and you can find it nottltd.com. And again, there's a little discussion here about the dissipation system in video as well, and it's well worth your time to take a look there. Okay, Mary, do you sell the NOT, or do you rep them?
I have. I don't know that I've had since I started with Broadcast Depot, but yeah, I've sold them in the past.
Mm-hmm.
So
Okay. All right. Well, then you can get information from their website or from Mary.